Oh, hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 6. It says, in the diagram, the graphs of f of x is equal to sine x minus 1 and g of x is equal to cos 2x are drawn for the interval where x is an element of negative 90 degrees to 360 degrees. Then graphs f and g intersect at A, as we can see here. Then we are told that B is a point on f, which we are given the coordinates of B is 360 degrees to negative 1, right? And then, okay, 6.1 says write down the range of f. So we can see that our graph of f is the one that is here below. So let me just highlight it so we can all see it. So this is the graph of f below here. And then we know that the range is just simply the minimum value of y to the maximum value of y. So a set of all possible y values, right? So for 6.1, since we can say that this graph here is just a shift 1 unit downward from the mother graph, we know that our minimum value now will be negative 2, while our maximum value is 0. So here we have 0, negative 1, negative 2. So the minimum value is occurring at negative 2, but the maximum value is occurring at 0. So that means we have y is an element of negative 2 is to 0. So negative 2 being the minimum value and 0 being the maximum value. Right. Then 6.2 says, write down the values of x in the interval x element of negative 90 degrees to 360 degrees for which the graph of f is decreasing. Right. Note that when they ask you questions about either decreasing or increasing in a graph can either increase or decrease from or to a turning point, right? So your point of reference when you are answering those questions is the turning point, right? Because from here all the way to the turning point, we can see that the graph is actually increasing. Then from here to this turning point, we can see that the graph is actually decreasing. From here all the way to that point, then we can see that it's an increase. So the way you answer these questions here is you try to break it from the turning point. So this is what you're going to do. You're going to try to break that graph from the turning point. And then we know that this increases if we put our straight line graph, and then our straight line graph ends up having a positive gradient. So if our straight line ends up being an increasing function, that means this is where the graph is increasing. But then if we were to put our graph in between those points, but then now we end up having a decreasing function, that means that is where the graph is decreasing. It has a negative gradient, right? So we can see from that observation there that this is actually decreasing in between these points, in between 90 degrees to 270 degrees. So in between the points 90 to 270. And then that is supposed to be our solution. We're going to say the graph of f is decreasing from when x is an element of 90 degrees to 270 degrees excluded. Why are we excluding the 90 and 270? Note that at 90, the graph is not increasing or decreasing because at that point, it's at the stationary point. That's a turning point. So a graph at the stationary point does not increase or decrease. It's simply just stationary there. So that means we are only saying that the graph decreases for points that are in between 90 to 270 degrees, but the 90 and 270 should not be included, right? Then 6.3, they say P and Q are points on graphs G and F respectively. So what this means is that P is a point on G and then Q is a point on F, right? So by respectively, they mean in that order. Then such that PQ is parallel to the y-axis. If PQ lies between A and B, now if they say if PQ lies between A and B, determine the values of x for which PQ will be a maximum, right? Okay, so let's understand this question here. So this is basically telling us that we want the points where we will have a maximum value in between A and B. If we put a straight line here, so the points whereby if we put a straight line in between, we will have the maximum distance between the graph of G and the graph of F. Now, we wouldn't know by just doing this, but then this is just a way to make you see the interpretation of the question. So this is where if you put a straight line, it will form the maximum distance in between the graph of G and the graph of F. So we are looking for the x coordinate that will give us that value there. Okay, so how are we going to do this? Suppose that we want to calculate the distance between PQ. Now that we are already told that PQ lies in between the points G and F, we know that P lies in the graph of G, so we'll have G of x minus F of x to find the distance in between PQ. So suppose that our PQ is this, let's say for argument's sake, then that means we'll take the graph of G subtracted by the graph of F, because P occurs at G and Q occurs at F. But then we do have the equation for G of x. That's cos 2x. Then we do have the equation for F of x. That's sine x minus 1. But then note that this cos 2x here is a double angle identity. Now this double angle identity can break down to three different forms. We can have cos squared x minus sine squared x. We can have 2 cos squared x minus 1, or we can have 1 minus 2 sine squared x. Now this is where it gets a bit tricky. How do we choose the correct one to use here? Now, a rule of thumb says if you are looking at the other one, the trig ratio of the other equation, and then you find that the trig ratio is represented in terms of sine, then go to this one and try to pick the one that only is represented by sine, so that you only deal with one trig ratio at a time. Right. So looking at this, we can see that this one has cos, so we can't choose that one. This one only has cos, but this one has only sine. So this is the perfect one, because this will ensure that we are only working with one trig ratio. Then we have 1 minus 2 sine squared x. Then if we multiply with the negative, that's negative sine x. And then negative and negative, that's positive 1. Right. Now, looking at this, we can see that we're going to form a quadratic type of equation here. Plus 2. Right? So the 1 plus 1 is plus 2. But then let's read again. P and Q are points on graph G and F respectively, such that PQ is parallel to the y-axis. If PQ lies between A and B, determine the values of x for which PQ will be a maximum. Now we know if we wanted to find a maximum in a quadratic equation or in a parabola, remember a quadratic equation is basically a parabola function, right? Now, how do we find a maximum in a parabola function that is a less than 0 or a being a negative? As we can see, our a is negative. We know that if our a is a negative, then this becomes a concave down graph, which has a maximum value. But how do we get to this maximum value? We get the maximum value first by calculating the axis of symmetry. So the x value that we are actually looking for here is the axis of symmetry. So this is that value of x that will produce a maximum, right? Remember, the maximum is produced by the axis of symmetry. So which is this x coordinate here. So how do we find the x coordinate of the axis of symmetry? From quadratic, we know that is x is equals to negative b over 2a. Since this is in quadratic format, we know that our a is negative 2, our b is negative 1, and then our c is positive 2. So we do not require the c for this equation. Then negative, we have negative 1 over here, and then 2 multiplied by what? Negative 2. So negative and negative, that's a positive. 2 times negative 2, that's a negative. So this is supposed to give us a sign. But then remember, we are not looking for x now. This is supposed to be sine x, because now we are dealing with what? The trig ratio. We are not dealing with x, we are dealing with the trig ratio sine x. So this is supposed to be sine x now is equals to negative 1 over 4, right? But then remember, we haven't found the values, right? To find the values, we should now continue further with this one and try to solve it as if we are looking for the general solutions, right? So now we are looking for the general solutions. So the negative 1 over 4 is now our value that we should use to find the reference angle. Now, if we are looking for the reference angle, we know that we are supposed to just write this one as a positive, so it becomes 1 over 4. And then this is supposed to be x, and then sine, and then 1 over 4 like that. So now you want to quickly just punch that into your calculator to find the reference angle. So our reference angle now becomes x is equals to 14.48 degrees. So this is our reference angle. But then looking at this is negative here. So that this is telling us that we should find our solutions in between the quadrants where sine is negative. Where is sine negative? We know that sine is negative in the third quadrant and also in the fourth quadrant. So going to the third quadrant, we're going to have x is equals to 180 plus our reference angle, 14.48. Then this will give us a value of 194.48 degrees. If we were to check for the solution in the fourth quadrant, this is x is equals to 360 minus the reference angle, which is 14.48. So if we say 360 minus 14.48, this gives us 345.52 degrees. And then this becomes our two solutions, because we are looking for the value or values of x for which PQ will be a maximum. So PQ will be a maximum at x is equals to 194.48 degrees or at 345.52 degrees. That's how you were supposed to tackle that question for 6 marks. So please take your time to understand the approach that I took in answering this question here. But with all that being said, we've came to the end of the lesson. Please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And then if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.